I recommend you attempt all the questions first before you watch this video for the solutions. That will be the best way of getting yourself ready for the upcoming test. Question 1 asks you to compare pairs of fractions. If we look at the first one, we've got 4/3 and 2/5. Now if you look at that, clearly 4/3 is greater than 1, 2/5 is less than 1. So the symbol you would have to put in between would be the greater than symbol. It's open to the larger of the two fractions. For B, we have two fractions and they're both less than 1, so we need to actually convert them both before we actually can compare. So the denominators we have here are 8 and 9, so I'm going to go for a common denominator of 72 for both of them. So the first one, 7/8, is going to be 7 times 9 over 72. And the second one, 5/9, is going to be 5 times 8 over 72. What I've done here is I've taken the denominator of the second fraction and multiplied numerator and denominator of the first one. And then for the second fraction, I've taken the 8 and multiplied top and bottom by the 8. So that's going to give me 9 times 7 is 63. So I'm going to have 63 over 72. Then I got 5 times 8 is 40. So it's 40 over 72. Clearly 63 over 72 is bigger than 40 over 72. So again, the symbol I'm going to have is the greater than symbol. With the final one here, we have two negative numbers, so I've got to be careful. The denominators are different, but I only need to convert the first one because 3 is a factor of 6. So minus 2/3 is actually going to go to something over 6. It's going to go minus 2. I'm going to multiply that by 2. So that's going to give me minus 4 over 6. So minus 2/3 is the same as minus 4 over 6. And then I've got to compare them, say which one is larger. Well, you've got to remember that although the 5 is a bigger number than 4, minus 5 is smaller than minus 4. So actually, we actually have another greater than symbol here, because we've got minus 4/6, which is a bigger number than minus 5/6. With question 2, we just need to, for 2a, we just need to simplify fully. So what we'll do here is we'll look at what is a common factor of 80 and 64. They're both even, so I'm just going to divide both by 2. So I've got 2 times 40 over 2 times 32. 2's will cancel. Then I look at that again, they're both even again, so I can say 40 is 2 times 20, 32 is 2 times 16. Get my 2's are cancelling. Both are even again, so I'm just going to keep going. 2 times 10 over 2 times 8. They cancel. And then they're both even again, so it's 2 times 5 over 2 times 4. So my final answer is 5 over 4. Now you don't have to do all the steps. You could have spotted that you were dividing top and bottom by 16. That's the highest common factor for both. Difficult one to spot, but you might have noticed it was divide by 4 or divide by 8, and that would have simplified some of the steps for you. Would have given you less steps. The second one, be very careful here. It says using prime factorization, so you must break up the numerator and the denominator first before you actually simplify the fraction, otherwise you will not be gaining full marks. So if we look at 70, 70 can be divided into 2 and 35. 2 times 35 is 70. 35 will divide by 5, so it's 5 times 7, and 7 is obviously a prime number. So 70 can be written as 2 times 5 times 7. Now let's do 120 as well. So I've got 120. It's even, so I got 2 times 60. Even again, so 2 times 30. This is nice, even again, so 2 times 15. 15 will divide by 3. 3 times 5 is 15. And 5 is prime. So 120 can be written as 2 cubed times 3 times 5 is cubed, because I have 1, 2, 3 2's here. Now I should look at seeing what I can cancel. The 5's will cancel. Multiplying by 5 divided by 5 just will cancel each other out. And look at the 2's. I have 1 2 on the top and 3 2's on the bottom. So the 1 2 at the top will go, and one of these 2's will disappear. I'm still left with 2 2's at the bottom. And that's all the cancelling I can do. So let's look at the fraction now. What am I left with? I'm left with 7 as a numerator. I'm left with 2 squared times 3 as a denominator. And that's going to give me 7 on the top. 2 2's are 4. 4 times 3 is 12. So my fraction simplifies to 7 over 12. Now clearly you can see that's correct. You could have just divided top and bottom by 10. But this question is checking the skill of prime factorization to simplify a fraction. So you must present this workings on the right, the numbers as the powers of their prime factors, and then all your workings through to cancel. That is very essential for that question. Question 3, we have some calculations involving negative numbers. The first one here is minus 17 plus minus 6. So that's just going to give me minus 23. If you think about temperature, if the temperature outside was minus 17 degrees and then it dropped by another 6 degrees, it would go colder to minus 23. But I'm simply, if I'm adding a negative, I'm simply taking that number away. For part B, I have positive 7 minus minus 4. Now remember, when you subtract a negative, it's the same as adding that number. So in fact, what I have here, I have 7 plus 4, which is equal to 11. A common mistake would be just to do 7 take away 4, which would give you 3, but that would be the wrong answer. It's minus a negative, so taking away a negative is the same as adding, so the answer here is 11. Now for C, we have multiplication and division. What have we got on the top? We have 3 times negative 2, so that's going to give me negative 6. And I'm multiplying that by 2 times negative 1, and that's over 6 times negative 2, which is negative 42. What else can I do? I can do 6 times, negative 6 times 2 is negative 12, times by negative 1, and that's over negative 42. And then negative 12 times negative 1 is positive, so that's just going to be 12, and it's 12 over 42. The question doesn't ask you to simplify, so you are welcome to leave that. I should leave the negative, sorry, at the bottom there. 12 over negative 42. You can put the negative outside. You could even put it onto the numerator if you wanted to. All of those answers would be correct. Now another way of looking at that question is ignoring the negatives, and let's just work out the numbers. So I'm going to do 3 times 2 is 6. 6 times 2 is 12. 12 times 1 is 12. So I have 12 as the numerator. 6 times 7 is 42. So I have 42 as the numerator. Now we look at the signs. I have a positive times a negative. So that's negative. Times a positive is still negative. Times a negative makes it positive. So my number on the top is positive. I have a positive times a negative on the denominator. Positive and negative is negative. So I have negative 42 at the bottom. That is actually a quicker way of doing it. Either method is suitable. Choose the one that you find most comfortable. And finally, we have a mixture of things going on here. You've got to remember the rules of the order of operations. So although we've got a subtraction, a multiplication, and a bracket, we do the bracket first. So I'm going to leave everything else alone. So I have 15, not minus 15, my apologies. 15 minus 6 multiplied by my bracket. My bracket is negative 8 plus 2, so that is going to be negative 6. The next step is do the multiplication. So I'll leave my 15 alone, 15, and then I have negative 6 times negative 6. That makes positive 36, so I'm adding 36. And then 15 plus 36 is going to take me to 51. So remember, with this sort of question, if there are brackets, you do those first. Once you've done the brackets, then you can do the multiplication, and only then can you do the subtraction. Here we had 6 times 6 is 36, negative times negative is positive, so that's why it became an add rather than a subtraction. You can look at it in a slightly different way, so I'll do the question again. I'll do this in blue this time, and I'll write it underneath. Again, let's just do the bracket first, and I'm going to have this is negative 6, And what you might want to consider is, okay, it's 15, take away 6 times negative 6. Well, 6 times negative 6 is negative 36. And as you can see here now, taking away a negative is the same as adding that number. So that is the same as saying 15 plus 36, which is what I did before. And my answer again, obviously, is going to be 51. So far, all the questions you've seen involve some form of workings, which you have to write down. So more sort of mental mathematics, but do write down your method. The final question you can use a calculator on. We're given a triangle and we're asked to prove whether or not it is a right angled triangle. So let's look at the numbers first of all. The 15 would be the hypotenuse if it was right angled. So if I label it A, B, C, I know that if it's right angled, BC squared would equal AC squared plus AB squared. So let's look at this. BC squared is equal to 15 squared. 15 squared is 225. Now, let's do AC squared plus AB squared. That is going to be 13 squared plus 8 squared. 13 squared is 169 and 8 squared is 64. 169 plus 64 is 233. And clearly that is not the same as 225. So we can see here that BC squared does not equal AC squared plus AB squared. So it's not a right angled triangle. And I should put a little sentence on there that according to Pythagoras, the square of the hypotenuse is equal to the sum of the squares of the other two sides for all right angled triangles. Make sure you put the statement as well, and then hopefully you will get full marks.